So by now you're probably used to the traditional model here of importing data, picking columns, splitting data, train, score, evaluate. Well, what I want to show you is a way to use the evaluate model pill a little bit better so that we can compare alternatives. Now in the past, if you've been following these chapters in order, these videos in order, we would simply replace out our algorithm here with different options, and then we would write down and record the R-squared or the accuracy or whatever evaluation metric we got of this pill into something like Microsoft Excel, print out a table of them and compare them. Well, that's a good idea if you're going to test a whole bunch of different algorithms. If you want just a quick and dirty, so to speak, way to compare a couple of different options, you can do something else like this. Let's grab all these pills here. We're going to copy, paste. I'm going to go ahead and make some more room here. All right, what I want to do now is connect my same data set into this select columns. I'm going to move that over, pull on my train model, score model, and pull this score model into the other side of evaluate model. So if you've been wondering what this is for, now you can see I can compare two different possible models. So for example, let's say I want to keep all of my columns, all of my independent variables the same. So remember, I just copied this one straight over. I'm going to delete out my logistic regression, and instead let's grab, let's see, I'm predicting a yes/no value of whether or not they purchased a bike. So let's get a to class something else. How about our boosted decision tree here? Perfect. Pull that in. Let's go ahead and run this. And I'll pause while it's running. All right, that's finished. Let's take a look. Okay, so again, in both cases, just like we've been doing before, we are predicting whether or not they want to purchase a bike. That's our train model in both. So let's go ahead and right-click and evaluate here. Visualize. So I love this chart. We've talked about it before. The area beneath this curve here, between the curve and this line, it indicates improved prediction. The bigger this area is, the more accurate our prediction is. So blue is the one on the left, red is the data set to compare. So blue is our logistic regression, red is our boosted decision trees. So what's interesting here is we can see exactly at what point each algorithm is better. So let's say I want to target only, let's say 10% of my customers to sell bikes to. If I want to target 10%, I'm going to come out here to the first 10% of the data and go up and see which algorithm is higher or further away from the line. In this case, it's actually the logistic regression. And it stays that way, it looks like, until right about here, about 18-ish%. But from 18% on, if I want to target, if I want to sort my data set by those that are most likely to purchase a bike, and I want to target anything above 18%, it looks like the boosted decision tree is a more accurate algorithm. It's one way to interpret that. So down here, it'll show me the details for whichever one is currently selected. So right now that's logistic regression. I've got my overall accuracy of 0.62. If I click on this one, now I can come down here and see my overall accuracy has jumped up to 0.70. So I like this because not only do I get the overall scores to compare like I could have gotten before, but now I have this cool chart that allows me to see, all right, at what point and where is each algorithm better than the other one. So there's other ways I can use this too. For example, if I wanted to keep my logistic regression, and instead I could compare, rather than a different algorithm, a different set of columns. So if you remember, we've had this issue with education. We don't know quite how to model it because it's rank ordered, but the distance between ranks is not equal. So we struggle with, do we classify it, or do we characterize it as a categorical value or as a numeric value? So let's say we want to just simply evaluate the difference between modeling education as one versus the other. So I'm going to remove the categorical version of education where it's simply text that says like, bachelor's, high school, graduate, and so forth, and instead use the rank ordered number version of education. And let's see what our difference is now. Run selected, and I'll pause while that finishes. Okay, that's all done. Let's take a look. Come on, there we go. Visualize. All right, so very similar. You can see it sort of crosses back and forth, but let's see what the overall difference is. So 0.623 accuracy for the categorical version and 0.617 for the numeric version. So although neither neither version of education is perfect the way we recorded the data, it looks like the one where we treat education categorically with no rank order implied is more accurate overall. Although if you look at the chart, you can see there's minor differences depending on at what point in the data set that I want to refer to. However, these are both close enough that I wouldn't really put a whole lot of stock in the difference from, for example, that to that right there, or even that to that. They're both pretty close. But anyway, the point of this video was not that. It was to show you how to use the evaluate model pill to compare two models side by side.